today I would like to talk with you a little bit about some specific detail, we could say, which is related to object-oriented programming, but not only. And this detail is quite important for you to understand how all this stuff works. So we are talking about references. So what do we mean by that? What do we mean by references? So first of all, let me give you an example. When we create integer variable, for example, like this, what happened inside our program or inside our rating system and all this stuff? So actually, when we declare or not declare, when we initialize this variable I and we put some value, that means that in our memory somewhere we have cell or we have place for this variable, and this place will be filled by this value. So this place will have name, which is I, and this place actually have value. When I create another variable, for example A equals 10, we create another place in memory with name A and with correspondent value. Okay, let me create one more variable, B. And yeah, again, I really need to initialize this variable. Okay, let it be 20 here. So yes, we have B. We have some value here, 20. So the most interesting part for us is following. When I want to write this kind of code, I equals B. I equals B. So tell me please, in terms of our memory, what should be done after this line?
I will be equal to 20.
I will be equal to 20. Yeah?
Yeah.
What that mean? So if we try to represent this, we will put, first of all, we will take value of B. So we access our memory. How we access? We know name. Okay, we access this place by its name. So we have this name B. Now we want to take value from this variable. So we know that value of this variable is 20. So we take this value here. We take this value. Then we search for another place, and we found this place by name I, and we should put another value to this place, and we put here 20. So if I make after that B equals 30, for example, will it influence somehow variable I?
No.
No, because I just put another value inside just this place, and I put 30 here and no connection at all with variable I. Okay, this is how we work with values in terms of primitive data types. Primitive like double, integer, boolean, and so on. So this is primitive data types. But when we talk about classes or even arrays, we meet absolute another situation. And now we should involve this concept, which is references. So let's try to represent that. We create, for example, we have some class student, which we mentioned before, have some members, setters, getters, methods, and so on. So we have this class, and we want to create instance of this class. So again, I have instance A. So what should I do? I mention data type, student, and my variable A. What next? New, exactly. So, because I'm creating new object, I'm creating new place in memory to keep this object there. So that's why I should use new here. And okay, and I place name of my class, and maybe regarding the constructor, there could be different signatures here, maybe parameters, but let it be just default constructor. So I just create this instance of this class, object of this class. Okay, what happened really in this case? Maybe I should move to another part of my whiteboard and draw it here. So, actual object really been created here, starting from this part. This part. Still, we don't talk about this part, okay? Just this one. Just created of new object. So we put this object somewhere in memory. Object of student, student object. And there are some initialization, for example, some name, surname, learning program, and so on. Maybe it is just default values or empty values or null values inside or members of this, but anyway, it is actual place in memory. So this is this part. What about this part? What about actual name A and this variable? The interesting thing that regarding the variable, we have something similar to our previous images. So, hopefully you still could see me who are online. So I have actual variable A, and I have some value here. And these two things somehow connected. So what exactly here in this value of A? Because I have variable A, and I should keep some value there. If you think that value should be this student object, then no, this is not so. Here will be actually reference. Reference or address or pointer to real object in memory. So this is some kind of address. This is the address in memory. So actually in variable A, we have address of the object. That's interesting, because yes, then I could access my student object by this reference. Of course, I could access members of this object, make some changes. I could write this. So in this line, what would happen in memory? In memory, be next process. I access variable A. Okay, variable A is of type object, so that's why it contains address. So that's why I access this address of this student object and put into name member, I put some specific value which is after equal mark. This is what happened actually in this during this operation. I access my object by address by this reference. Okay, that's interesting. Next, for example, I have another variable, student B. And I create new object again, new student. What happened here? Again, I created new variable, a new place in memory, which I could access by name B. But here, I will get what? Reference to newly created object, because here I have this part with new. That's why that means that in memory, in another part of the memory, I'm creating in heap, we call it. But it's not so important at the moment, so how we call it. But another part of the memory, we have another student object with some fields. So again, then I move here and put B name equals Roman, for example. And after that, I access this variable, take this reference, access this object, and put into name specific value, Roman. Okay? So this is the difference between primitives and reference types. So reference types, it is objects, it is arrays. Actually, string is also kind of reference type, and it is a bit complicated story there. But maybe I will back to that. But now, in general, I would like to you to follow this idea. So next, let's move to another interesting moment here. As you see here, we had this operation, I equals B. Let's imagine the same here. So I could write it, this code higher. If I implement this string, B equals A. B equals A, okay? I run command, B equals A. What happened there? What do you think?
It has the reference on the same object.
It will reference the same object, yeah? So actually, we will have the same as here. So we access B. Okay, B is this place in memory. Okay, then we access A. A is this place in memory. So we take value of A. Value of A is what? It's reference. And we put this reference inside B variable. And now what happened? Now, let's say it is address this, and address of B was something like this. But now I decline this previous value of object B, and I put this another address here. What means that B now pointing to what? To first object. Absolutely. And now I have no reference to this object. To this object, I have nothing at the moment which points to this object, correct? Because I have this A, B, and nothing else, and this object, nothing is pointing to this object.
But this object still exists?
This is a good question. And I will answer this very important question. But first of all, I would like you to understand that now we have actually two variables. No, I would like to grab all. Two variables which points the same object. Two variables, but the same object. Wow, that's interesting. You could imagine that, like, for example, alias in your operating system, in your file system, or how we call that, remind me in Windows, I forgot just, when you have just shortcut, just alias of your file. In macOS we call it alias. In Windows, shortcut. Yeah. Okay. So you have just shortcut to your file. You could have many shortcuts to the same file, correct? This is absolutely the same. This is kind of shortcuts to your actual file. This is shortcut to your actual object in memory. So the most interesting now thing, when I type b name equals Andrei, what happened now?
Well, like for A and for B, the name will be Andrei.
For A and for B, the name will be Andrei. Exactly. So what happened in memory?
In our first object, instead of Petro, we'll have Andrei.
Yeah, this exactly. This line means that we put Andrei here. This is it. We access this object. So interesting, the more interesting thing now that if I want to output system out println a dot name, what will I get in console? I will access the same object and I will get Andrei. Despite that here I have direct line which put kind of into name of A, put Petro, but in console I will get Andrei because through B I changed the same object, correct? Do you see the idea? And question of I1. What happened with this object? And now we come to concept of garbage collector. This is part of modern languages. When without our direct actions, Java garbage collector will watch to any object in memory, and in case if this object have no other references, garbage collector will consider this object as a garbage and will delete that from memory. And actually for us it is good news because we should not do it. Java will do it for us. In C++ you should do it by yourself. If you have no any references to this object, it is your responsibility to free up the memory, or you will have memory leaks. You will have problems. Your application will consume memory without need and so on. So this is actually good news that here we have garbage collector.
It's like how we can in C++ they're using the object without the name, how we can output connect with it.
What do you mean? To free this object?
We have the object A and object B, but how we can output for the object that we don't have the name for it?
Yeah, so actually we don't need to output anything from this object, because if the logic of programming that if you have no references to that object, maybe that means that you don't need that object anymore and you would not like to output anything from that object.
We need to delete it for our own, but how we can...
Yeah, but to delete that, maybe we should perform some action before this line. So before this line, we still using pointer to this object, because at this point we still have this pointer. We delete object B from memory using B, and then use this this value to put another reference. Use variable to put another reference to that. Okay.
But you told that in C++...
In C++, you could use this B.
Yeah, so we can use it in the future. We can use a reference for the object that was played.
No, we delete this, and at this line using I actually don't remember how to do that. So
it's saved, and we need to delete it from.
we delete that, and it is not exists. So we will not use it in the future if we delete that, okay? So before this line, okay, we do not study C++ now, come on, okay? So it is not so important to, but just in principle, you could delete using B, and this object will not exist, and B will point to null, to nothing, and then you use B and ask, oh, B, now please point to this actual object. And B will not null, but will point to this object. Okay, kind of that. So the idea is just that we should not play so deeply with pointers here in Java, but in C++ it is kind of very, very important stuff to play with pointers, to actually deal with all of that. For example, we could not get this pointer of A in Java, yeah? Because actually it is someplace in memory. But in C++, we could actually even get pointer to A, to address A and then address value separately. In Java, we could, for primitives, just access direct this variable and that's it, just by value. But just say, yeah, about, I don't want you to mess and to think about, to overthink this, but just to mention that pointers, it is quite a huge subject in C++. But now we with Java, and Java with garbage collector, and this syntax a bit helps us to work with references or pointers. But here we call it references, it is more correct for Java. Okay. Now, one more thing for you to understand, and to let me emphasize one important stuff, one important point for you. So imagine that we have some method, or a method, let me call it, a method. And this method accepts a variable of type integer. And in this method, I make, for example, a++, and do nothing. This is the body of my method. So the question is following. If I declare variable a and put value 10 here, then I call a method and put this variable a here. And then I want to print system out println again a variable. Okay, please pay attention. I declare variable, I initiate that variable with 10, then I call a method, this method do something, and I print this variable. What be in console?
It doesn't return.
It will be
11 or 10? Let's think about that. So, actually, let's back to our primitive variables. So when you create a variable a, we created this memory place. Then we call method with and put value of this variable into that method. The truth is that we do not pass reference to this variable, but we actually do remember call stack. We call a method, so we create this additional place in memory, now in call stack. We put address, how to back from this call stack, how to back here. Also, what should we place here? You remember? Parameters, yes? So, we put parameters here, and here we put value 10. Parameter with name A. But you should understand that this place in memory and this place in memory, just different, absolutely different places. So when you pass variable into method, that would be absolutely different variable. This variable have no any relation to initial variable. This variable in this method and all you do to that variable have no any relation to initial variable. So you put 10 here, okay, that means that we created another place in memory, then we make a++, okay, we change, we have additional kind of place here, we change that, and what? And nothing, okay, we then put out this variable, this call stack reference, we put it out, but we didn't do anything to initial variable. This initial variable is just not connected to this call stack and all these local variables and so on, local variables of this method. This is absolutely another story. So that's why, again, what you get in console?
10.
You will get 10, you will not get 11. You will get 10 because we call it, and now you should write it. It is passing parameter by value. Pass parameter by value. So when you have integer, boolean, double, primitive, any primitive data type here, that means that you pass parameter by what?
Value.
By value, not by reference, but by value. That means so if it by value, then you put just value, but without any reference to initial variable. No references here. Just value, and that's it. And you forgot about any connection with this initial variable, okay? Understand? Yeah.
Can we put a reference there?
Okay, now this is the question. So what about objects? Now if I have another method, and this method has another signature, student, and let it be S. And I put name, I put name here, Stepan. This is all I do. And again, here I have new student, I put another name here. Which name? You decide. What name would you put here? Okay, Alexander. And I call a method and pass this object into this method. Okay? And then I want to system out println as name. What will I get?
Stepan.
I will get Stepan, or I will get Alexander. What do you think?
Stepan.
Okay. Because what? Because
You put reference in your call stack.
yeah, exactly. We put reference here. In this call stack, we put not value, but we put reference to this student object. With at this moment we have Alexander there. But then this reference comes to this method. I access the same place in memory, despite I have another name, for example. Oh, it's actually as here and there, but it could be any variable name. But I still access the same place in memory. I change that place, so I write there Stepan, the same into same place in memory. And then I come back from this call stack, from this method, I come back here, and I access the initial variable, but initial variables still have the same reference on the same object. So that's why I play with the same place in memory when I pass parameter by what? By reference. So you should know that we could pass parameters into method by value. And what second? By reference. Please remember that. We have two types of passing parameters. Passing parameters by value, passing parameters by reference. And as a conclusion, let me tell that if you have array, array is also reference. So if you pass, and that's why we actually had this. So you could have array, you put that array into user input, do you remember that? Please user, and you have in that method user input, but you change initial array because you pass a reference. You're not getting another copy of your array, you play with the same array. So if you pass arrays in your methods, you actually will work with the same place in memory. So you just should know that arrays and objects always accessed by reference. And when you pass parameters as objects or arrays into functions or methods, they always access it by reference. Okay? Yes, so this is it. This is Java syntax for you. So again, in other languages, for example, in Pascal, you could choose. Would you like to pass this parameter as a reference or as a value? Here you could not choose that. Java choose for you. If it is primitive, you pass by value. If it is object, you pass by reference. This is it.